Sounds far-fetched at the moment, doesn't it? But you know, we may be seeing ads like this in the not-too-distant future. In fact, there's the equivalent of a small bungalow out there in space right now that's empty and available, with a beautiful view of Earth. Skylab, a bungalow that has already had 9 tenants. The main purpose of Skylab was to make space flight more useful for man's endeavors on Earth. As NASA Administrator James C. Fletcher put it, Skylab marked the transition from exploration to the exploitation of space. As has been said, the average taxpayer is entitled to ask, what's in space for me? Well, the results from Skylab will, we hope, answer that. Let's take a look now at the development of the Skylab space station itself. As I said before, this was really an economical venture to which the earlier major space programs contributed greatly, enabling the Skylab project to use flight hardware already in existence. It's 48 feet tall and 22 feet across, with a 13,000 cubic foot interior, 10,000 cubic feet of working space in the main section alone, the equivalent of a small family bungalow. Skylab is divided into a lower floor with crew quarters, wardroom, and medical experiment area, with an upper floor for space technology equipment. The multiple docking adapter provides docking ports for the command module, as well as housing the control console for the solar telescopes, and a series of cameras for conducting Earth resources observations. The command module, used to take the astronauts to and from Skylab, is identical with that used on the Apollo flights, and left over when that program was cut back. So, as we can see, much of the hardware needed for the Skylab program was already available. The unmanned orbital workshop was launched in May of 1973 atop a Saturn V rocket from Pad A, right here at Kennedy Space Center in Florida.
10, 9, we have ignition sequence start. The engine's now building up to 7.7 million pounds of thrust. We have a launch commit and we have a liftoff. The swing arms moving back.
When the flight was scarcely a minute old, a serious problem developed with the workshop. Mounting temperatures in the workshop indicated the failure of the meteoroid shield, which was actually torn off by the slipstream during launch. An hour after launch, the ground controllers in Houston were still waiting for confirmation that the workshop's solar array panels had deployed, a signal they never received. Of course, the launch of the first Skylab crew scheduled for the next day had to be postponed until solutions were found. The urgent need was to stop the rapid temperature rise, which was immediately accomplished by ground control in reorienting the workshop so it was no longer broadside to the sun. The next 10 days were hectic. Immediately, teams were formed to provide answers to the problems. A major objective was to design and fabricate a thermal shield that could be deployed on the workshop to make Skylab habitable. Throughout the United States, teams worked round the clock in an all-out effort to perfect such a design. Meanwhile, here at Marshall Space Center in Huntsville, Alabama, crews were evaluating installation of a parasol device in the Skylab underwater simulator. In conditions approximating zero-G, they also trained underwater in methods of freeing the jammed solar panel. But the actual work would have to wait on an eyewitness assessment by the astronauts in space. Time was becoming critical if Skylab was to be saved. Relief would come only from the thermal shield parasol, which would be deployed by the astronauts when they arrived at Skylab. During the early morning hours of May 25th, almost 10 days after the original schedule, a Saturn 1B was ready to launch an Apollo spacecraft for the first manned visit to the Skylab orbital workshop, with astronauts Conrad, Kerwin, and Weitz aboard.
We have launch commit and
Skylab 1 was on its way. The first step in the fulfillment of an opportunity to use men in space for practical humanistic benefits. By mid-afternoon, the crew rendezvoused with Skylab and performed a televised fly-around to assess the damage. Most of the predictions were confirmed. The meteoroid shield had been ripped away, exposing the workshop's skin to the sun. One of the solar array panels had been completely torn off, and the other, only partially deployed, was held in check by an aluminum strap, a fragment of the meteoroid shield. As astronaut Conrad put it,
Expected solar wing 2, right, is gone.
an unsuccessful attempt was made by Weitz at freeing the panel, working in the open hatch of the command module before docking with the workshop. After a night's sleep aboard the command module, they entered the workshop and took steps to deploy the parasol. In mission control, optimism that the mission would be saved wasn't long in coming, as external skin temperatures began dropping rapidly, and within the workshop too, they had started to fall. The parasol was doing its job, but there was still a shortage of electrical power. The stuck solar wing would have to be pulled out fully. Thanks to the work of the backup crew at Marshall, where procedures were worked out for freeing the solar panel.
All the attention I can take.
Astronauts Conrad and Kerwin went on their first spacewalk to repair the damage. This took 3.5 hours, and it was difficult work. But man prevailed, and they were able to sever the strap and pull out the panel.
Let go, let go, let go. All right. It's got it.
Within hours, the power situation was nearly normal. The mission could continue. A mission transformed from near ruin to success. From the beginning of manned space flights, there's been a concern about the ability of man to survive flight through space and be able to perform satisfactorily in prolonged periods of weightlessness. This was a major concern and objective of all 3 Skylab missions, and was especially true on this mission. For the first time in space, there was a medical doctor aboard to supervise the tests in the Life Sciences program, astronaut Dr. Joseph Kerwin. This lower body negative pressure test provided valuable information on the cardiovascular system, carefully checked and monitored on the control panel, which supported all medical experiments. A measure of motor sensory performance, an experiment designed by a high school student, using a punchboard apparatus for eye-hand coordination to measure changes in motor sensory skill of the crews. Balance, orientation, and perception, so important to man's ability to function efficiently in space, was another of the life science tests. The astronauts were instructed to exercise frequently, and one of the techniques was the ergometer, or bike, to help keep them in shape. This also served as a test for possible changes in metabolic activity while working and living in a zero-G environment, as well as a check on heart rate and blood pressure under these workloads. Throughout each mission, a vast number of tests were made on eyes, ears, nose, throat, and blood samples were taken and returned for post-flight testing. Actually, we've seen only a small portion of the medical tests covering muscle and bone development, heart and blood tests, perception and equilibrium, and even cell growth. The ability to monitor, record, and transmit medical information over such a distance on the most advanced equipment yet devised will prove invaluable and undoubtedly be adapted for use in hospitals here on Earth. The tenets of Skylab certainly indicated that men could live comfortably in space for long periods of time with no apparent harm. It can be said that with Skylab, we have completed the most extensive medical space missions ever flown and learned many new things about man in weightlessness. Outer space is a truly revolutionary platform for materials processing. Since all of the adverse effects of gravity are absent, this makes it possible to perform operations in materials processing and manufacturing that would be virtually impossible here on Earth. Many space processing experiments were performed aboard Skylab in a vacuum chamber and heat treating apparatus, including an electron beam gun and small electric furnace. The formation of crystals might well be the most valuable of all the manufacturing experiments. This resulted in crystals 10 times larger than those grown on Earth, with a much better uniformity of composition, so important in the modern field of electronics. This will result in systems that will perform more functions, will be faster, will require less power, will be smaller and less expensive to manufacture. The pocket computer, so widely used and popular today, is a direct result of space technology. As Professor Harry Gatos of MIT says, it is no longer a matter of speculation that materials processing in space presents one of the greatest opportunities ever afforded to benefit mankind. And kids, when it comes to blowing bubbles, how about this? You can puncture them, pull them and pick them up, but they still won't break. As you can easily see, getting from place to place is no problem in Skylab. Weightlessness can be lots of fun too, as Pete Conrad shows as he exercises, much like a squirrel in a cage. No circus acrobat or Olympic swimmer can match this. We all know Alan Shepard was the first to play golf on the moon. Well, here's the first space ball game ever played. The first 3 tenants of Skylab returned to Earth after 28 days in space. When trouble developed at the start of this mission, we might have despaired and written off Skylab as so much space junk. However, that was unthinkable. What the ground teams and astronauts did in saving the project, moreover, proved the crucial value of man in space. Future missions were assured. Early one morning, late in July, a month after the return of the first crew, Skylab 2, the second manned mission, was launched, with astronauts Bean, Lausma, and Garriott aboard.
And the second manned crew has cleared the tower.
During the 8-hour chase of Skylab, one of the 4 thrusters used for maneuvering their command module sprung a leak. Mission Control ordered the astronauts to shut the leaking assembly down. Bean still managed to dock perfectly. Six days later, another thruster sprang a leak and had to be shut down. The thrusters are needed to orient the capsule so that its main rocket can fire in the right direction for safe re-entry and return to Earth. For the first time in the manned space program, NASA had developed the ability to perform a rescue in space from a disabled vehicle. Round-the-clock preparations were immediately begun to activate the Skylab rescue vehicle, the rocket assembled and an Apollo craft modified. The Saturn 1B rocket was rolled out to the pad, ready to launch the rescue ship into orbit. Meanwhile, the 2 leaks were found to be unrelated and not as feared indicative of a general system breakdown. Computer studies and ground simulations showed that the capsule could be steered with half its operating thrusters, and the astronauts were told they could stay aloft for the 59 days as planned and continue their scientific studies and experiments. The most important package of scientific instruments on Skylab was the 12-ton telescope mount with its 8 solar telescopes to permit a study of the sun. The importance of these studies and benefits cannot be exaggerated, especially when we consider the natural resources and energy crunch that is upon us today. possibility of this research teaching us how to better harness this energy to power our cities and homes with an inexhaustible supply of clean, non-polluting power becomes a major goal. When people think of astronauts, they usually visualize them as high-ranking military officers and daring test pilots, forgetting that some are also scientists with advanced degrees in physics, electrical and aeronautical engineering, and medicine. The value of men in space as true scientific partners in space science research is most evident in the Solar Studies program, because that allowed photographic film to be used, resulting in spectacular photographs being returned to Earth. Pictures such as this can only be made from space above the Earth's atmosphere with a special instrument, a spectroheliograph. Notice the comparison of the size of Earth with the large eruption of the sun's atmosphere. Other wavelengths were used to help follow changes in the sun apparent when this photograph was analyzed. Such X-ray photos permitted further coronal study, unveiling faces of the sun never before seen by Earth-bound observers, giving radically new knowledge of the sun and ways it may affect the Earth. Solar studies and stellar astronomy were features of all three Skylab missions, and this solar flare, photographed on the third mission, was the most spectacular ever recorded, radiating more energy than has been used by man since the beginning of civilization. The sun has no energy crisis. It puts out the entire annual world energy demand thousands of times each second. This gives added meaning to the words of Wernher von Braun when he said, "We hope one of these days to harness this energy on Earth." High priority was also placed on a machine that would allow an astronaut to move freely about outside a spacecraft. Using the Skylab's upper dome area to explore this kind of flying characteristic, the astronaut uses a maneuvering unit which could shuttle him between spaceship and satellite. This will prove to be invaluable in space flights of the future. There were also 19 experiments carried out specifically for high school students. One brought other passengers aboard Skylab 2, the spiders, Anita and Arabella. This was an experiment to find out the structure of the web they would spin in the weightless state. They soon adapted to space and spun a web quite easily. There was a problem, though. When they ran out of food for the spiders, they shared bits of filet mignon with them. Oh, for the life of a spider in space. The Skylab 2 crew spent almost 14 hours in spacewalks, augmenting the parasol with a twin-pole sunshade, changing film for the solar telescope, and retrieving canisters containing over 77,000 pictures of the sun from outside the workshop. After 2 months and some 24 million miles, the scientific journey of Skylab 2 ended, bringing back scientific data and secrets of the sun that had been kept secret for billions of years by the dense blanketing of Earth's atmosphere. In November, after a 6-day delay to replace cracked stabilizing fins, the third mission soared aloft with astronauts Carr, Gibson, and Pogue.
Lift off, the engine's building up to 1.6 million.
Skylab 3, the longest of the manned space missions. One of the major projects on all three Skylab missions was the Earth Resources Experimental Program, which will certainly show the man in the street that space can be of everyday use in solving some of the world's most pressing problems, such as pollution, locating resources, and feeding the hungry. Special cameras were designed for this work. This program again brings out the importance of having men in space, for the astronauts were trained to observe specific places on Earth. They brought back photographs such as these, taken in the visible and near-infrared wavelengths, resulting in countless discoveries about the Earth in many different fields, in the inventory of water resources and study of pollution, seen so clearly in this photo of Lake Michigan in the Chicago area, in regional planning and development. Here we see the densely populated area of Baltimore and Washington, D.C. Information obtained will result in better warnings given of impending storms, such as the astronauts observed from space in the Caribbean and Pacific. This photograph of Hurricane Ellen in the North Atlantic revealed that the walls of the eye of a hurricane were sloping, which caused energy to be fed into it, a fact heretofore unknown and of utmost interest to meteorologists. In agriculture, for crop census and yield, soil moisture, and crop infestation. For example, in photographs of the desert areas of Africa, discoveries were made of the extent of damage caused by drought and incorrect cultivation methods. Valuable discoveries were also made in the field of geology to help locate natural resources, minerals and oil, so important to the world today in the light of critical shortages. Faults and changes in plate motions of the Earth, never before seen by man, were observed and studied, as were forests and range. Oceanography, the study of current flows and eddies, such as the Falkland Current, never before photographed. Aids to ship navigation, to lessen the possibility of damage to cargo and ships, and reduce the chance of major oil spills. Mapping, especially in such areas as this in South America, never before done accurately. This perspective from an orbiting spacecraft, such as Skylab, gives us a better way to inventory and monitor our resources, and provides us with information at a cost we can afford. While it will take years to study and analyze the thousands of pictures taken from Skylab, we cannot overestimate their actual value in improving our life here on Earth. Meanwhile, let's go back to the comfortable environment of life in space. And speaking of comforts, the comforts of home were not neglected either, as the astronauts could enjoy weekly showers, and if they could find a foothold, wash and shave, and even prepare their own food to individual taste. No more just eating out of a tube, as on earlier space flights. Crewmen enjoyed space luxuries never before available. Even man's sleep was monitored by a cap with sensors, as each astronaut bedded down vertically in a sort of sleeping bag in his individual sleep compartment, or should I say, stateroom. It was found, by the way, that the quality of sleep compared favorably to the astronauts' normal sleep pattern on Earth. Determining weight in a weightless world is a real problem. With no gravity, there is no weight, and normal scales cannot be used. Since many of the biomedical experiments require measurement, this odd-looking chair was devised and used to keep a careful check on the weight of the astronauts. Small masses were also measured on a device so sensitive it could determine the weight of a postage stamp. The next time you do your push-ups, try this. It was quite a chore when the astronauts got ready to go outside for a spacewalk. Fast action photography, however, makes it look easy. It is much like suiting up Junior to go play in the snow. The Skylab crew spent 21 and a half hours outside the workshop in spacewalks, changing and retrieving film, observation, and repairing equipment. As on all three missions, Earth observations continued. While Skylab centered most of its work on practical uses of space, its crew didn't neglect precious opportunities to enrich science's knowledge. Cameras zeroed in on promising targets of opportunity, of which the most noteworthy was the comet Kohoutek. While its observations from Earth were not as spectacular as hoped for, Skylab's solar telescopes plus 2 spacewalks with portable cameras gained amazing results. Actually, the Skylab instruments were the only means available to scientists anywhere to observe the comet during its close passage to the sun, as this stop-motion film shows. The fact that the astronauts were able to observe the comet at this time and even make sketches proved scientifically valuable in collecting basic data needed to make the greatest advance in cometary research since Halley's time. While we were celebrating the holiday season of 1973, each in his own way, there was a special celebration aboard Skylab 3. the Skylab Christmas in Space. And of course, that included the stockings, hung by a very unusual Christmas tree, painstakingly constructed out of food cans and decorated by the astronauts with a very special star on top, Comet Kohoutek. And now, a Christmas message from space, showing concern for people everywhere.
From the Skylab 3 crew, we wish to extend to people around the world the message of peace, goodwill, and human understanding.
After setting a new record of 84 days in space, the third manned Skylab mission ended with a splashdown and recovery in early February of 1974. It's impossible to single out one thing as the most important among the more than 2,400 experiments performed during the Skylab missions on a flight path that covered almost 75% of the Earth's surface. It is certain, however, that Skylab has established a basis of factual data for the design of future space systems and the planning of future manned operations in space. Even more important, it has demonstrated that man has important work to do in space. And for humanity in general, there is no doubt that this use of space makes an important contribution in allowing man to manage his affairs here on Earth more in harmony with nature. Before the crew left the space bungalow, they configured it for a possible revisit by somebody, perhaps by the future space shuttle, or as the space administrator said, a little green men from space. The orbital workshop will continue in a 270-mile-high orbit for 10 years or more. It's up there right now. Maybe you'd like to be the next tenant. 4 rooms, beautiful Earth view.